In the following example, we're going to integrate this function using trigonometric substitution. U substitution wouldn't work because u would have to be under the root here, leaving 2x dx for du. We have dx over x, which we can't make equal, so we're going to try to use this substitution. We have x squared minus 25, which fits a function squared minus a constant squared, telling us that we have a secant substitution. So in this case, x is going to equal 5, because a squared is 25, secant theta. Derivative then gives us 5 secant theta tan theta d theta. And we can go ahead and substitute here. We get the integral of 25 secant squared theta minus 25 all over 5 secant theta times dx, which is 5 secant theta tan theta d theta. Now we just need to simplify and get it to an easier form. So if we factor out the 25, we end up with 5 outside the root. Inside the root, we're left with secant squared minus 1. Secant squared minus 1 is tan squared under the root, which means when we take the square root, we just get tan. That's tan theta over 5 secant theta times 5 secant theta tan theta d theta. So if that part caused you a little problems, just try to work it out on paper separately maybe. Take out the 25. It's under a root, so outside the root is 5. Secant squared minus 1 was tan squared. We take the square root of that. We're left with just tan. Now we just cancel the 5's. We can cancel a secant, and we're left with 5 times the integral of tan times tan, which is tan squared theta d theta. Tan squared we can't integrate directly, but tan squared is equal to secant squared theta minus 1. Doing this substitution again, and we can integrate secant squared. The integral of secant squared is tan, and the integral of 1 is theta, and plus a constant. So we have our integral. Now we just need to replace tan theta and theta with the corresponding x value. So we'll draw a reference triangle, put in theta. We know that secant is x over 5. Secant is hypotenuse over adjacent, which makes this side over here x squared minus 25 under the root from the Pythagorean theorem. We need tangent, so tangent is opposite, which is root x squared minus 25 over adjacent, opposite over adjacent, which is 5, so the 5's will cancel there. And 5 times theta. Now theta, we can't write directly, but we can say sine of theta is root x squared minus 25 over x, opposite over hypotenuse, and then take the inverse of that to find theta. So theta is going to be sine inverse of root x squared minus 25 over x plus c. So if we write the final simplified form, then we get the root and 5 sine inverse x squared minus 25 over x plus a constant.